Hi, everyone. My name's Trudy, and to add my own perspective onto the introduction from Christopher, I've had a through line working at Google and also at MIT where I've been building AI tools the entire time. And I think it's really fun when you can make AI tools feel magical, but I think it's more impressive and even harder to do when you can make the AI tools feel approachable and uncover what's happening under the hood. So today, I want to talk about two things. I want there to be two takeaways for you from this talk. First, I want to talk about the algorithms behind search and AI generation, and you don't need to come away a computer scientist expert, but I would be super happy if you knew the differences between the algorithms of search and AI generation. And then I want to talk about why I think all of us should be AI literate and why we should be confident about asking critical questions about tech and what's happening under the hood. To start, I think there's a big conflation right now between search and AI generation. And this is understandable because almost all of the mainstream interfaces that we have right now for them are just a simple text input box where you can type in any question, throw your question up to the answer gods, and wait for a response back. This is really, really tricky and gets borderline dangerous. Because this is functionally the same as if you walked into an office building and there were two elevators that looked pretty much identical, and when you step in, the floor selection keys are all look the same, and then the floor that you are delivered to and how you get delivered there by the elevator could be completely different. The mechanics of how the elevators work could be completely different under the hood. This is like search and AI. Okay, so we're going to do a high-level overview of the two algorithms that are the foundations for both search and AI generation. And to start, we're going to talk about PageRank, which is used by lots of search engines, and there are lots of other things that happen in search engines, but this algorithm is the one that's the backbone of modern web browsing. And the fundamental idea is that the more links that a web page has pointing to it, the higher it's going to rank in your search results. So let's step through a toy example of the algorithm now. So we can imagine a small network, this toy network of 5 websites, all of the circles, and the links pointing to the top website mean that that top website ranks the highest in the PageRank algorithm. It has the most links pointing to it. But also, PageRank considers how important the websites that are pointing to a website are. So not only is PageRank going to consider the number of links that are going to another website, it's going to consider the importance of the website that's also linking to it. So in this example, the bottom 2 websites, the little 2 circles on the bottom, might be websites that are like smaller blogs or less popular, and those links would count for less for the ranking of that website. And then you could imagine if there was a giant news outlet or something that referenced your website and had a hyperlink pointing to it, that would count as a higher weight to push your website up on search results. And so PageRank itself is an iterative algorithm that will keep an index of the flow of all of the links passing between websites so that it can keep track of which websites should appear at the top of your search results. And so this is, again, just the foundations of the algorithms that power search results. There's a lot more that's happening with search, but the key takeaway to remember is that when you search something on a web browser, what's happening is you're having a search and retrieval of an existing website that's weighted based on relevance and popularity of the website. Okay, cool. That's the basics of search. And so now I want to talk about the transformer model, which in this big AI boom, there are lots of different AI models, but this big AI boom that we're experiencing now is all thanks to this transformer model architecture. And to be clear, there are lots of other architectures, but this transformer model architecture is the most popular one that powers all the LLMs that we're all familiar with. Okay, to understand the fundamentals of how AI generation works, we're going to use the metaphor of a classroom. And let's imagine a classroom that is filled with books and papers and artifacts from all over the world. And let's imagine that we have a child as an AI model in this classroom. Actually, we are not going to imagine the AI model as a child. It is not a child. It is not a person. We are not in the business of anthropomorphizing AI. It does not have any insights or personal knowledge of its own. All an AI model is a very advanced pattern recognizing bot. Okay, so we'll call it pattern bot for the sake of this explainer. And before PatternBot is allowed to answer any questions that come from a human, it has to go through a training stage. And so what happens in the training stage is that an AI model is going to read and ingest all of the information from the internet and that it's provided with, and it's going to mimic the patterns of how humans speak. So to be clear, it was a blank slate before, and then it's going to save essentially a probability sheet of all of the ties between phrases and learn how humans talk. Okay, so the key insight here is that as a pattern bot is learning all of this information and it's in its training stage, it's not reading like you or I would. All it's doing, it's not discerning, all it's doing is it's mimicking the patterns of human speech that it's seeing over and over again and saving an average of how likely those phrases would be saved together. And that's essentially what a neural network is. Okay, so when you ask an AI model a question, there's something very different from search that happens. An AI model is going to try to predict the most likely next word. So when we look at this diagram up here, what's happening is when we're outputting the phrase to be or not to be, that is the blank. The blank here is determined by the AI model as the most likely next word, given the phrase that came before and all of the training data and patterns that it's learned from its training stage. So in this case, the most likely next word would be question. It's at like 56%. So there's something really uncanny that happens here because an AI model is learning the patterns of human speak, okay? So it's learning the syntax of how humans have talked. And so the semantic meaning underneath is a little bit skewed. The patterns are simply how humans talk, and it's an average of how those patterns have showed up in the information in the training data. Okay, so at a high level, the takeaway of how AI generation works under the hood is it's a one-by-one prediction of the next most likely word based off of all of the training data that the AI model has seen and saved in its probability sheet, its neural network. Okay, I promise that's all of the algorithms and step-throughs of diagrams that we're gonna do. Now we're just gonna talk about metaphors and what all of this means. So I think when we think about search and AI generation, we have to be very clear about what's happening under the hood. And I use this metaphor of either picking out a ceramic mug from a cupboard, or getting a paper mug generated for you on the fly with AI generation to differentiate between search and AI. So let me explain what I mean by that a little bit more. When you're going to search something, what's actually happening under the hood is the search browser is going to look through all of the existing human-made things on the internet and then pick for you the thing that looks closest to that. So we can think of it as the same as when you go to a cupboard, you're gonna pick a ceramic vase made by human with real human virtue from a cupboard of things that already exist. And so this is great when you want real human perspective and you want real human virtue that's in the thing that you get back. AI generation is sort of the flip side of this, right? So like we talked about, AI models are really great at pattern recognizing, and they're able to make things for you on the fly. That's a really cool insight. And so it's really great in a situation where you want to create some artifact that combines a lot of patterns. Let's say you need to write an email, and you need it to be in a specific tone for a specific scenario. It's great at matching up tone and scenario for a starter email template. Or let's say you are reading a biology paper with super dense biology topics and you need it explained to you in very simple, plain language terms. Again, very good at pattern recognizing of, okay, here's the core idea of the very complex research paper, and here it is in natural language. It's great at bridging those patterns. And then also if you're a coder or a developer, it's great if you have a lot of libraries that you want to have as maybe like starter boilerplate code. You can say, given all of these libraries, can we then bridge all of these patterns to make starter code? So the key takeaway between search and AI generation is one is like reaching to grab an existing object, and then AI generation is like making a like 80% there quality thing that bridges all the patterns that you want. Okay, so why AI literacy? Why is it important that you care about what's happening under the hood for these giant algorithms? I think we can all feel it from all of the talks here, but AI is at an inflection point, right? We are now at a point with AI where the models are the most capable that they've ever been, and they're also the most accessible. So when I say capable, I mean these AI models are really good at generating things that you need, complex questions, and they're getting convincingly better and better. And they're also extremely accessible. Any one of you can go build any piece of software or tool that has AI in it, because the APIs to access these AI models, extremely accessible, and generating code is getting easier and easier. People who are able to make AI models are more empowered than ever right now. Or not AI models. Tools that have AI models in it are more empowered than ever. I mean, you could make an AI model, but whatever. And I still think that there's a gap between the research of these foundational AI models and a lot of the tools that actually touch us, with the exception of conversational AI interfaces. So I'm talking about things like ChatGPT or Google's Gemini. I don't think that there are that many AI tools that have reached the mainstream zeitgeist and are touching all of us in our day-to-day. And that's a pretty good thing to be at, because that means that all of us can build it. And so I think of it right now as we have this power grid of infrastructure of AI. AI is going to be an enabling technology like electricity. And I think about, like, we have laid the foundation of these AI models that all of us are going to be able to tap into and use to power our tools and solutions and systems. And we're going to be the ones who are going to be able to build the things that tap into this infrastructure. And I'm sure that all of you are going to be asked in some solution, brainstorming idea, like, should we add AI to this thing? And the only way you're going to be able to know if you should add AI to this thing is if you actually understand what's happening under the hood. You're actually able to know, okay, what are the benefits, what are the affordances of the type of algorithms that are in AI? And we can actually decide how we want these tools to feel. And so I'll leave you on this note of, I think that there's a reflex right now to make AI feel magical. You want it to feel hand-wavy, you want it to feel light, you want it to feel very airy. But there's something dangerous that happens there, because when you make AI feel airy and light, you remove the ability for people to ask questions about it. And so instead, I think that we should think about designing AI to be very visible and very clear. We should make it very understandable what's happening under the hood. And I think we should instead design AI to feel very approachable for people. We should be able to give them the opportunities to ask questions. And the only way that we can do that is if we know what's happening under the hood of the algorithms for ourselves to make these decisions about how to design AI. Thank you.